going to talk about solving rational equations. What's rational mean again?
Real.
What did you say?
Comes out nice.
Comes out nicely? No, guy. That's hard to say. Rational numbers can be ugly.
They end.
What's that? Positive or negative? Well, when I say they can be ugly, I meant that most of you don't like these. What are they? What do you need, lead? They're fractions. Remember, rational means that it's A over B, where A and B have to be integers with no common factors. Okay. So, what size do you need? Oh, I have that. I'm recording all this now. Here we go. So rational numbers, irrational equations just mean they have fractions in them. And you've solved those kinds of equations before. Before we get into this, remember we talked the other day, what do you think extraneous solutions are? Extraneous solutions.
Is that when it's like undefined or like it has like square root or something? Or it doesn't make a asymptote or something like that?
Yeah, you're right along the right track there. Remember when you're solving an equation and you do nothing wrong? And it doesn't work, does it? Okay? I said we did this the other day. I might have been thinking geometry did this the other day. That'd be my mistake. But you've done this before. Extraneous solutions mean that they're equations that you've solved, you've done nothing wrong, you've done everything correct, they just don't all work. Okay? They don't all work. So what are some reasons you think that they occur?
Have non-real numbers.
They have non-real numbers, exactly. Or, same thing, yeah. Imaginary, non-real. What else could they have? We've been worried about these. We've been working on not allowing this to happen or identifying where they happen. No? What'd you say? Well, what created the hole? Having the same what kind of number? 0. Right? So what created the hole isn't that the top had the 0, it's that the bottom had the 0 and the top happened to have the same one, right? So we said non-real numbers, that's one of the reasons that they occur. Another reason is that they are undefined. You can't divide by 0. Okay? Why might we want to check our work then when we solve equations? Make sure you did it right. That's one reason. Good.
Or to see if they're extraneous.
Yeah, exactly. To check to see if they're extraneous. Okay, that's the biggest reason. We're going to assume that we do everything right in here, right? But even if we do, some of these aren't going to work, so we have to check our answers. So today, when the directions say solve and check, it's not like when you were solving equations back in whatever grade you started solving equations, 6th, 7th grade, and they said check your work, show your check. Okay? They wanted you to better understand what you were doing, and you were just beginning, so you may have actually made a mistake once in a while. Here, I'm going to assume you know what you're doing, and you're doing it correctly. But they don't always work. Okay? So, in this first example here, it's kind of ugly with those multiple terms in the denominator, but what kind of equation is that? Fraction, okay. Rational, yeah. Good. What else do you notice about it? shot. No wrong answers here.
Well,
Some more right than others. No wrong. What's that?
It's got a square deck.
It's got a square in it, yeah. What else do we notice about it? What'd you say?
I don't know.
Yeah, okay. You probably don't need to record that. What do you think, Jared? What is it called when one fraction is equal to another fraction? When one ratio, isn't a fraction a ratio? Yeah, when one ratio is equal to another ratio, it's called a proportion. That's all this is, isn't it? So how do we solve proportions? Cross multiply. So on the left, I'm going to have,
6x squared minus 18.
let's actually show it out before we do it out, okay? Let's show what we're doing so that we don't lose anybody. So you said 6x times what, Chandler?
X minus 3.
X minus 3 equals, and I know it's not necessary to show, but again, just so that we don't lose anybody later, the other one is 1 times x minus 9. What's important when I show it out like this? What is important that I do? And to make sure I distribute, that's correct. To make sure I distribute, if I was showing this step, what would I have to have in it? I did put it in there, so I'm just, parentheses, that's correct. I need to make sure that I put my parentheses in whenever there's more than one term. That's a single term and that's a single term. So we don't need parentheses around them, but this is 2 terms and 2 terms, and we need to have parentheses around them. Okay? To make sure that we distribute. And Chandler, you'd already said this side. What was it?
6x squared minus 18.
That's correct. And the other side, then, what do I get? Anybody?
X squared minus
Mr. Mitchell, is
I
that
think
18x?
Oh, thank you. That's correct. 18x. Got me overlooking that too. Good catch. Good catch. Now, we have what kind of an equation? It's not rational anymore. It's what?
It's an equality.
Hunter, you pointed it out, I thought.
What?
It has what in it?
Squared.
Squared, which makes it what kind of a function?
Um,
Quadratic.
Yeah,
So,
quadratic.
to solve quadratics, remember we spent a lot of time on this. To solve quadratics, we could graph them, couldn't we? Okay, we could factor them, or we could use quadratic formula. Very good. So, in graphing, we could deal with it the way it is. Well, we're not going to graph today. So, what do we have to do with the elements of this equation in order to either factor or use quadratic formulas? Set it equal to 0. That's correct. Do you agree they both have an x squared on them? Both sides, I mean? Well, does it make more sense to bring the smaller one over to the left so it stays positive? Okay, so let me erase those lines. So if I do that, I have how many x squareds?
5x.
5x squareds minus 18x plus 9 equals 0. Very good. Okay? Now, some of you are not excited about factoring this. Can someone else tell me why your neighbor might not be excited about factoring this? Because there's a 5 in front of the x squared, isn't there? Yeah, that's right, Thomas. But the nice thing about this is how many different ways can you multiply 2 numbers to get 5?
1.
1. What is it?
1 and 5.
1 and 5. And so the only way to get 5x squared is 5x and 1x, right? And the only way that I can get a positive number here is if both of these signs are the same as this, right? So they both have to be negative. So the only thing I have to worry about is how do I get 9?
1 and 5.
9 and 1 or 3 and 3. I have to multiply, remember, Chandler? So 9 times 1 or 3 times 3. And so if I tried 9 and 1 and I did this, my outer 2 would give me a really big number, wouldn't it? And I want 18, not something around 45, right? So that didn't work. If I tried the 9 here and the 1 there, I would get 5x, and the inner 2 would give me 9x. That's how many? 14x's, right? 9x and 5x? 14x. So that doesn't work either. So how else could I get 9? 3 and 3. And so the outer 2 gives me 15x, and the inner 2 gives me 3x, right? 15 and 3 add up to 18. So that works. So now it's factored. Okay? So this means then that x is equal to 3 or 3/5. That's right. Okay? Now, so what do you think's under the yellow dot?
The answer? Probably the answer.
Okay? The number's 3 and the number 3/5. Okay? What does it say in our directions?
Check.
Check. Well, it could be both. It could be both, but it's possible it's only one. It's even possible it's none. Okay? So let's look here. What do we think about 3? When we throw 3 in here, is that going to work?
No.
No. Because what's 3 minus 3? And what's 1 divided by 0? Undefined. So that doesn't work, does it? So 3 is not going to work. Okay? Now if I plug 3/5 in there, I'm going to get 1 over 3/5 minus 3 equals 6 times 3/5 over 3/5 squared minus 9. Now how many of you are excited about working that out by hand? Not many of you. Not many of you are excited about that. But the nice thing is you have this little gadget on your desk that's yellow. And on this, oh, sorry. And in this gadget here, you can do, what was it, 1 divided by 3 divide 5 minus 3. And get what? Negative 5/12, right? Okay? And then we can do the other one, which was, let's go to a fraction this time. So we had 6 times 3 divide 5. On the bottom, 3 divide 5 squared minus 9, right? What's that? It works, doesn't it? So that one worked. So that's the nice thing about your calculator. You don't have to do that all by yourself if you don't want to. And we agree, the answer is 3/5. Okay? The answer is 3/5. Now, I want you to try this one. Spend the first 3 minutes trying it on your own, and then share with your neighbor and make sure they know what they're doing. I know that you know what you're doing, but your neighbor might need a little help. So you try it first, and then talk with your neighbor about how to work this out, okay? Okay, come back to me, please. Guys, I don't want to take up all our time when we may not all be going in the right direction. So let's come together and you help me do this problem. What's the first step? Let's say Cody's group. Someone in that group help me out.
Cross multiply.
Cross multiply. So you're saying, oops, there, sorry. There we go. Now it's working. You're saying do that, right? And so what did you get when you cross multiplied? What did you write on the left side?
4 times 2x minus 1 in parentheses.
Did you really write 2x?
No, I squared it.
Oh, okay, good.
That's all it is.
In parentheses. Good job pointing that out. Okay? Equals?
12 times 3x plus 3 in parentheses.
Okay, good. Very good. Did anybody disagree with that first step? Did anybody's neighbor make a silly mistake on that first step?
I did.
Okay. Can you share what you did to see if that's something that's common that
Well, I
someone
just
needs to
forgot
be
to
careful?
times the 1 by 4.
So you
I
forgot
got
the concept of parentheses and
Well,
distributing.
I just skipped that step and it just times in my head.
Right.
I did it on the other side. I just forgot to do it on the.
That's though why I said to everybody, let's go ahead and write this first one out this way on our first example, because that's a really common mistake. We just get into distributing right away and we don't write it down, and then we actually don't distribute. And if you notice, if you go back and realize, I forgot to write that X down also, didn't I? I mean, I did write what Chandler told me, but the fact of the matter is I didn't catch it. I usually write what you say, even if I know you have a mistake. This time I didn't catch it. It's because we're looking on to the bigger picture instead of focusing on the little bits and pieces. So don't forget the parentheses. Let's go to this group right, Chandler's group here. Somebody in there tell me, what do I get on the first line now? The next line, I should say, not the first line. What do I get when I do this? What do I get?
4x squared minus 4.
4x squared minus 4 equals?
36x.
Oops, 36x
Plus 36.
plus 36. Okay. You said it, I just didn't hear you. I'm sorry. All right. Now, the next line. Jared, your group here. What do I get now?
4x squared minus 36x minus 40.
Okay. Equals.
0.
Okay. Good. Are we all excited about factoring that?
No.
What does every one of those terms have in it? A 4. And since every term has a 4 in it, if we took a minute and divided everything by 4, what would I get?
X squared
Minus
minus
9x.
Oops. Is that?
Minus 9.
It's minus, right?
X squared minus 9.
Minus 10, right? 40 divide 4. Now, does it look like it'll be easier to factor? Yes, it will. What goes in the first of each of the parentheses? X. What's our signs have to be? A plus and a minus. That's correct, because the only way to get a negative 10 is if I multiply a positive by a negative. Right? It's the only way. Yeah. Negative 10 and a positive 1 will give me a difference of a negative 9, won't it? So what do I get for my x's?
Negative 1 and positive 10.
Negative 1 and positive 10. So let's go back up here. -1 and +10. Let's see, we wrote -1 first. Will that one work?
No,
No, why not?
because when you times it by, or when you do the 3x plus 3, it makes a 0 in the denominator.
Ah, he's saying that when I plug it in here, -1, -1 times 3 is -3 plus 3 is 0. But also over here, what happens when I square it? I get a +1, 1 minus 1 is 0. So that one failed on both sides, didn't it? So that one's not going to work. So how about 10? Yeah, it will. You agree 10 works? 10 squared is 100. 100 minus 1 is 99, so we get 12 over 99. And here we get 33, 4 over 33. And 3 goes to both of these, doesn't it? 4 times and 33 times. So our answer is 10. Okay? All right. I want you to take 2 minutes. Please have real discussion on this topic, not the scrimmage tonight or anything else. Talk for 2 minutes about how this problem is different than the previous 2 we just did. Go ahead. We're recording that 2 minutes. Sorry about that. If you're at home watching this, Maddie. Okay, let's come back. I think our 2 minutes is up. You're close. So, tell me one thing your group said.
The x is there. That screws everything up.
The X is there, messing things up. What are you saying? Okay, how about you guys? Same. My daughter's new favorite line, same. What do you guys think? Come on, you had a couple just a minute ago. You just told me. Give me one.
X in the numerator.
There's an X in the numerator this time, okay? How about you guys? There's a minus X. Ah, it's no longer just a proportion. There's no squared. Do you guys have anything different to add? Okay. I think the key here is that we recognize that there's a lot of things going on that are a little different. That minus X is the same thing Chase is saying. It's no longer just a proportion, is it? Okay? But we could make it a proportion if we wanted to take time to create a single fraction here instead of 2. We could do that. Typically not what we want to take time to do, though. Okay? So remember back in the day, when you're solving equations and you had fractions, we multiplied all the way through by the what? What about the denominator? Did you say it? Who said that?
I didn't say it.
Did you say it, Lon? Okay. By the LCD, right? What's that? Least common denominator. So we're going to multiply all of this by the least common denominator. Okay, now pay attention. What we do what we're going to run into is going to be some confusing fractions before we're all done. Okay? So our setup today, there's a reason for me suggesting you take time to look at it this way. Not because of this problem. This is the easiest of them. Okay? But because of the problems we're going to run into later. So I suggest you go through and look at every denominator. What's the denominator here? A 1. Okay? This is a 4. And so what I'm going to do, I'm going to multiply everything by this denominator. And I'm going to go on. Okay? If I multiply by 4, do I have a 1 already? How do I get 4? 2 times 2 or 4 times 1. So if I multiply by 4, I have a 1 in my 4, don't I? 1 times 4 is the same. So I'm good there. Let's go to this one. An 8. Do I have an 8 already? No, but how do I get 8?
2 times 4?
2 times 4. Do I have the 4 already?
Yeah.
Yeah, so what else do I need? A 2. I need to have every factor that's in the denominators out front. So as I go through, I needed a 4. Then I needed a 1. Well, I already had that. That was 4 times 1. And then I get to here. I needed a 2 times 4. Well, I had the 4, I had the 1, but I didn't have the 2, so I had to add my 2 out there. So really, I'm going to multiply everything by 8, aren't I? Okay? Now, I'm going to go real slow with this. 8 times 1/4 minus 8 times x equals 8 times x over 8. Okay? I'm showing that step on purpose so that we don't forget to distribute. Okay? We want to multiply every term by 8. And so what is 1/4 of 8?
8 32nds.
No.
Oh.
Remember, it's 8 over 1. It's 8/4. What is that? 2. Minus, what's this term? 8x equals x, because my 8's cancel, don't they? Okay? So then if I add 8x to both sides, I get 9x, right? And now what do? Divide by 9. X is equal to
1/3. Oh.
2 ninths. Okay? 2 ninths. All right? Now, only one answer this time, isn't there? Because, as Thomas noticed, there's no squares. Okay? It's not a quadratic. So do we need to check? Do we need to bother checking our answer? Yes, you do.
Yes, we do.
Always need to check your answer. Because I still could have a 0 in the denominator. I still could get into an imaginary situation. So you have to always check your answer. Okay? Again, though, you can use your calculator. 1/4 minus 2 ninths. Is that equal to 2 ninths over 8? Use your calculator. The answer is yes. It does work. Okay? Okay, this will be our last one. And tomorrow we'll look at this one. See how it's a little more involved?
A lot more.
Okay? So we'll save that for tomorrow. We'll cut those 5 problems out of the homework today. So you're only going to have like 6 homework questions or 5. Okay? All right. Maybe 4. Try this one. I'll wander around watching. All right, here we go. Now, first thing we want to try to do. Now, maybe, Emily, we need a little more practice with it. But the first thing we want to try to do is identify what? The LCD, the lowest common denominator, or the least Common denominator. So I look at every denominator. What does this one have in it? A 3 and a 1 and an X. Okay? We'll ignore ones. That thing misled us a little bit last time. Okay, we go to the next one. What do we need? A 3. Do I already have a 3? Yes. So I don't need another one. So I go to the next one. What do I need? An X times X, right?
You just added it.
And I only have 1, so I need another 1. Okay? So now, spend 2 minutes trying to take that on from there. Because many of you are stopped at that point. Right. 8. So, when we multiply this, we have 3x squared times 11 over 3x minus 1/3 times 3x squared. Let me rewrite that so I have a little consistency. I was putting my 3x squared term first times 1/3 equals 3x squared times negative 4 over x squared. So when I multiply this, I look for what they have in common. They both have a 3, they cancel. This has an x squared, this has an x. So my x cancels with one of those, leaving me with what on top? Times 11. That's 11x, right? And then we go to the next one, minus. What do they have in common?
3.
A 3. So I left with
X squared. Oh,
x squared. I go to the next one. What do they have in common? The x squared. So I'm left with negative 12. Now, you notice my x squared's negative over here?
Yeah.
So it'd be better if we moved all of the left side over to the right side. So I'm going to get a positive x squared over there, a negative 11x, and the negative is still, the 12 is still negative. This isn't writing very well today when it's recording. What do I get then when I factor?
X minus 11 and x plus 1.
No?
Minus 12.
X minus 12 and
1.
Oh, yeah.
X minus 1.
x minus 1.
Yeah. No, X plus 1.
Yes, x plus 1. Okay? So what's x equal? 12,
12 or negative 1.
negative 1. So what do I have to do with them?
Check.
Check them out. Make sure they both work. Okay? In this case, they both work. Okay? In this case, they both work. Any questions on this? All right. Today, I want you to do the 5 problems that are in black. 2, 4, 12, 16, 21. This is lesson
9-6.
Anybody know what page it is?
Yeah.
Thank you. Just do these 5 today. We'll do another example tomorrow, and then we'll add those 4 and a few more review to make sure we have enough to understand what's going on.